Hey guys, good afternoon and welcome to RT Success Mechanical Engineering. This is the seventh video in our YouTube session and it is the second chapter and first part or first set for the second chapter, heat and mass transfer. We have done the first chapter, industrial engineering and production management, with 6 sets, and we are going with more 6 sets in this second chapter, heat and mass transfer, and this is the first one. Let's start with the first question. Unit of thermal conductivity in MKS unit is kilocalorie meter per hour meter square degree centigrade. Let's move towards the second question, and second question here is thermal diffusivity is a physical property of substance. Unit of thermal conductivity is joule per meter Kelvin second, and joule per second is also watt. So watt per meter Kelvin is also the unit of thermal conductivity in SI units. So option B and C both, that is option D, is the correct answer. Which of the following statement is wrong? The heat transfer in liquid and gases takes place according to convection. This is correct. The amount of heat flow through a body is dependent upon the material of the body. This is also the correct. LMTD, logarithmic mean temperature difference, is not equal to arithmetic mean temperature difference. The option D is also correct. So the incorrect option is option C. The thermal conductivity of solid metals with rise in temperature normally. Now we have Q equal to Ka dt upon dx. So thermal conductivity is inversely proportional to the temperature. So with rise in temperature, thermal conductivity of solid decreases. In free convection heat transfer, transition from laminar to turbulent flow is governed by critical value of free convection is governed by Prandtl number and Grashof number. Now, the condition for thermal conductivity and temperature for non-metallic amorphous solids is directly proportional. So with decrease in temperature, the thermal conductivity decreases. According to Dalton's law of partial pressure, barometric pressure equal to partial pressure of dry air plus partial pressure of water vapor. Heat transfer takes place as per second law of thermodynamics. The heat transfer by conduction through a thick sphere is given by Q equal to 4 pi K R1 R2 T1 minus T2 by R2 minus R1. When heat is transferred from one particle of hot body to another by actual motion of the heated particles, it is referred to as transfer of heat by actual motion of the particles. It is convection. When heat is transferred from hot body to cold body in a straight line without affecting the intervening medium, it is referred to as heat transfer by radiation. Sensible heat is the heat required to increase the temperature of a liquid or vapor, but the latent heat is the heat required to convert water into steam and superheat it. So here for the sensible heat, increase the temperature of a liquid or vapor is the correct option. Heat transfer in liquid and gases takes place by convection. The heat transfer takes place according to second law of thermodynamics. Which of the following in the case of heat transfer is radiation? So heat received by a person from a fireplace is the radiation. Thermal conductivity of water may increase or decrease depending upon the temperature. Heat is closely related with temperature. If the thickness of thermal and hydrodynamic boundary layer is equal if Prandtl number is equal to 1. Pick up the wrong case. Heat flowing from one side to another depends directly Q equal to Ka dt upon dx. So for with dx thickness, it is inversely proportional. So for directly, the wrong case is thickness. Unit of thermal conductivity in MKS is kilocalorie meter per hour meter square degree centigrade. Thank you for viewing the video. We will be soon with next video for set 2 of second chapter, heat and mass transfer. Thank you from RT Success.